All right, I want to do a few examples of balancing equations here so you have something to work on. Uh, the hints that I give to you are these. Start with the most complex looking compound, and next would be to leave hydrogen and oxygen to last. Okay, there are a few other little tips and tricks we may get to, but those are the three main things that you should keep in mind. Most complex thing first, hydrogen second to last, oxygen last. Okay, so let's apply that. So it's all about counting atoms. And if you're not sure how to do that, then you're going to have to go back and learn how to count atoms. But let's assume that you do know how to do that. So here we've got one nitrogen in the product side. Then we look over here, we've got two nitrogen. So to fix that, we have to put a 2 coefficient out front. That just changed how many hydrogens we had here. So that's one of the reasons why we would leave hydrogen till later. So now we've got 2 times 3 is 6 hydrogen. So to fix that, we put a 3 right here, making 6 hydrogen. Okay. Always go back and recount everything, but this one's pretty straightforward. This one should be all balanced. This, even though there's a blank here, it's implied that there's a 1, but you don't really need to put a 1 there because it's implied. Okay, next question. Potassium chlorate, we have 1 potassium, and on the reactant or product side, we have 1 potassium, so they're good. Chlorine, 1 chlorine, and 1 chlorine, so they're good. The problem here is with the oxygen. We've got 3 and 2. So that's an awkward number because of this 3. It's an odd number. And what we'll have to do is find a common denominator between 3 and 2. And you should know that that's 6. So how do we get to 6 from 3? We'll have to put a 2 out front here. So now we've got 6 oxygen. Okay, so now how do we create 6 oxygen here? Simply enough, we put a 3 as a coefficient in front. You're not done because by putting this 2, we just affected how many potassiums and chlorines we have. Simple solution, we'll put a 2 in there, and you'll see we have 2 potassium and 2 chlorine. Okay, so now that one's done. Okay, most complex thing, that's almost a tie here. So let's just start here. Sodium, 1 sodium, 1 sodium. Great. So go back, 1 chlorine, 2 chlorines. Okay, so now we know we have to put a 2 in front here to fix the chlorine. And keep in mind, we just adjusted the sodium. So let's fix that right away. And now we have 2 sodiums. Okay, the other thing to keep in mind, if anything is by itself like this, then you want to leave that to last as well, because you can always adjust that to be whatever you want it to be without really affecting anything else. But in this case, we're all set. 2 is a coefficient in front, making 2 fluorines, and we've got that on the reactant side already. So that's a third example for you. Okay, here is some hydrogen gas getting together with some oxygen gas, and those are a couple of our diatomics. They go around in twos, just like this fluorine was, and we're producing H2O. So right away you see the hydrogen is fine, but it's the oxygen that there's an issue. So we need to put a 2 in front here to make 2 oxygen, but then we just created more hydrogen on this side. So to balance that out, we've got to put a 2 here as well. Okay, next we have, let's say this is the most complex looking thing here. We've got 1 lead and 1 lead, so that's balanced. Next, even though this hydrogen and oxygen are in the more complex compound, they're hydrogen and oxygen. Leave those to last. So we'll move on to this compound here, seeing that we've got chlorine. And on the product side, we've got 2 chlorine. So to fix that, we're going to put a 2 here. Okay, now you can see that we've just, through doing that, we've got another hydrogen here. So good thing we didn't start playing around with hydrogen yet. All right, so next, let's take a look. Let's look at hydrogen. We've got 2 because of this subscript and 2 right here. So that makes 4 in total on this side. So to get 4 here, we'd have to multiply by 2. Now, as it would be, the oxygen has sorted itself out. We've got 2 oxygen here because of that subscript and 2 oxygen here because of this coefficient. This one's all done, but do go back and recount everything as a verification. Okay, we'll do 5 more, and then that'll be the end of our demonstrations here. So we've got Next, let's say this is the most complex looking compound here. We've got 2 aluminums. Go back to the other side. We can see we've only got 1. So we have to put a 2 coefficient out front. Next, there's a bit of a shortcut we can do here. We've got this SO4 is all packaged up in brackets, and it appears on the other side over here as an SO4. So I could say, how many SO4s have I got? Well, I've got 3 of them, so I'd put a 3 out front here. If we didn't see that, that's fine too. I might just go on and say, how many sulfurs have I got here? Well, I've got 3, and I need to put a 3 out front. So we'd end up in the same place. So next is our oxygen. Just to check, I've got 12 and 12. This one is not quite done. We've got the bromines here. So we've got, and the potassium. We've got 6 potassium here. So we'd have to put a 6 to make 6 potassium. We've just made 6 bromine as well. And that we already have here is because the coefficient and the subscript together. Okay, this next one is the combustion reaction for methane. And let's start off with this CH4. We've got 1 carbon and 1 carbon. That's good. 4 hydrogen, only 2 hydrogen. Coefficient 2 goes out front there. Oxygen. This one's alone, so you'll have to always leave that to last. So let's count up the right side. We've got 2 here and 2 because of here, so that makes 4. Simple enough, we put a 2 out front. Okay, next one. This is propane, and we've got 3 carbons here, and so we need a coefficient of 3 out front here. Again, then we'll go to the hydrogen. We've got 8, so we'll need to put a coefficient of 4 here. 4 times 2 is our 8. Okay, so next we've got 3 times 2 is 6 oxygen, plus another 4 oxygen makes 10 oxygen. So to fix that problem, we'd have 5 oxygen. Okay, next we've got C8H18. So we've got to put an 8 here for carbon, and we've got 18 hydrogen. So we'll put a 9 here. So this is a good one to do because this involves the last little trick that I want to show you about. And we go on to the oxygens. This oxygen will be last because we can adjust whatever we want here without affecting anything else. So let's do a quick count up. We've got 8 times 2 here is, make a little note, 16, plus another 9. That's going to be 25 oxygen. So to get to 25 by multiplying by 2, we can temporarily use a decimal. Okay? And now this technically satisfies everything, but we can't go around saying we've got half a molecule. So what we end up doing is multiplying every coefficient by 2. All right, so this one is a 1 implied, times 2 is 2. This goes back to 25. The 8 goes to 16, and this will go to 18. Okay, just do a quick check to be sure. We've got 16 carbon, 16 carbon. We've got 36 hydrogen and 36 hydrogen. And we've got 50 oxygen, and here is 32 and 18 is 50 oxygen. Okay, next, yeah, you might want to just clean this up on your paper, but I just was leaving it there to show what I was doing. Okay, so next, I don't know, let's look at this iron oxide as the most complex thing. We've got 1 iron, 1 iron, oxygen and hydrogen, let's leave that. So let's move on to the next. We've got 1 sodium, 1 sodium. Where's our chlorine? Okay, chlorine, there's 1 and 3. So we will need to put a 3 here to fix the chlorine. That affects our sodium, so we need to go back and put a 3 sodium. You can see by doing that, we just affected our oxygen and hydrogen. So we would like to sort that out now. And, as it is, 3 times our OH gives us 3 OHs. So there you go. Good luck.